double entry ledger system came to be, and I say, well, what other technology or logic underpins society in such a wide and pervasive mechanism today? We now just have this 21st century version of double entry ledger keeping, which we're still understanding, but I think of equally as dramatic. So thank you.
Next up, we've got Dave MurrayRust from. You're actually in design.
I'm in design informatics, so I spend most of my time. Yes, please. I spend most of my time on the floor above this.
Okay. So I'll let you get set up. I just wanted to sort of back up a little bit because I'm not hugely technical. That's an understatement. So what I'm more interested in is the kind of potential kind of implications and applications of what's going on under the hood. And I think the thing that really sort of captured my imagination and why I jumped on blockchain, Ethereum, and all of these types of technologies is it just dawned upon me how potentially game-changing and disruptive this will be to our everyday lives. So about 10 years ago, or thereabouts, we transitioned from Web 1.0 to Web 2.0. So instead of passively consuming data, the flow of data, in a single direction, we transitioned into Web 2.0, which is a human-centric internet, so that people could communicate in two directions. So send and receive, and as a result, we've got Facebook, Twitter, LinkedIn, the social web. It's a people-centric web. That's going to end pretty soon. We're transitioning now into a machine web, okay? Web 3.0. The number of machines connected to the internet currently outnumber the number of people. Very soon, there will be way more machines connected to the internet than people. So the data originating from humans is going to be a tiny little side note compared to the volume of data originating from machines. Now, think about this stuff. Suddenly we've got a decentralized peer-to-peer internet. You're cutting humans out of the equation. You will have smart objects that will be able to pay for themselves. They'll be self-governing through smart contracts and cryptocurrency. So you'll have autonomous vehicles that will have maybe a Bitcoin wallet, who knows? But it'll be able to pay for parts, electricity, and it'll conduct itself in a fully autonomous manner, aside from any human overlord. That is the new web. That's the Web 3.0. That's the machine web, the machine economy. And it's thanks to these technologies that are very early stage, very nascent. But once they start getting mainstream adoption, we're going to be living in a very different world because all these devices are going to be powered by artificial intelligence and robotics. So it's worth considering. Exciting, scary, in equal measures perhaps. So Dick, over to you. Thanks very much.
Thanks very much. So I used to be a computer scientist, and now I've fallen in among designers. And that means that what I tend to do a lot more of now is talk about values and how we understand the ways that people value technology differently and the different things that people do value in these things. And one of the things about the blockchain is it's complicated. It means a lot of different things to a lot of different people. And so it takes a bit of unpicking to figure out what's important in different contexts. So I'm going to start in the pub, because that's always a good place to start. This is the Haymakers in Cambridge, and a while ago they started allowing people to buy beer with bitcoins. So this is the very first till receipt that they had, where someone actually did a bitcoin transaction and got a pint of beer in response. And this is one of the views that people have of it. It's a way that you can pay for things. It's a different kind of currency. You'll hear people say it's a ledger. Currency kind of works sometimes by being a method of accounting of who owes what. Ledgers used to be books, now they're decentralized. You'll hear a lot of people talk about it being anonymous. And yet you can look at companies like Elliptic who are going, and because it preserves every single transaction that ever happened on it, you can start unpicking who did what and when, and you can start actually re-identifying the people that have carried out transactions on the system. So it's a way to spend money, it's a way to keep track of accounts, it's a way to have a whole history of a million different things that happened. it's also a way to write graffiti, because alongside the financial transactions, you can store arbitrary data. So people are using it as a publishing platform. This is TextBlock, which is an RFC for how you do permanent publishing using blockchains and some other kind of indexing so you can find it again. So it gives you a way to write things that then persist forever in some sense, or at least as long as people keep running these things. So it gives us this way of looking at data where it goes out and it can then never change. So you can start thinking about provenance, and you can start understanding where data has come from and what's happened to it in the future. It's also a wonderful way to generate entropy in the form of heat. This is Genesis mining. This is one of their Bitcoin mining rigs. It's now not cost effective to be a Bitcoin miner unless you live somewhere with cheap electricity and you can get cutting edge circuit boards. Otherwise, you pay more for the electricity than you get paid back in Bitcoins. And all of these machines burning vast amounts of power. I think the Bitcoin network is about 500 megawatts at the moment, which is fairly substantial, and it's doing all of that to run 7 transactions per second, which is nothing. If you compare that to Visa, they're doing something like 100,000, I think. So there's several orders of magnitude in efficiency. All of these computers are doing useless problem solving. They're trying to find a hash with a certain structure, and the more computers that get added to the network, the harder they make that difficulty. So they make sure that even as we add more and more machines and we burn more and more energy, it still takes 10 minutes to find the number that makes each block work. And there's nothing magic or special about those numbers, except we've said they're important to Bitcoin. So it's a great way to generate waste heat. And we see some people rethinking around that. This is Joseph Lindley's crypto heater that was a creativity and cognition last year, where he said, right, well, if we're accidentally generating waste heat with all this computation, let's take the Bitcoin mining rig and attach it to a radiator, and at least it can keep my house warm. So that's an example of rethinking some of the values around these systems. And part of that is going, which bits of this are important to us? If you say, I'm not too worried about complete decentralization, I'm happy to have one trusted party in there somewhere. You can talk about centrally banked cryptocurrencies. This is a paper out of UCL, George Danazis and Sarah Michaeljohn. And they can create a network that is orders of magnitude more efficient than the Bitcoin network, because they're happy to have one central point in there that verifies things. So it means if you're thinking about doing stuff on the blockchain, you have to figure out what's important. This is from a page.
Sorry, could you define for a layperson what the blockchain is?
Right, I haven't been doing this in this talk. I could do an intro.
Or does everyone know? Am I just...
And I kind of assumed that other people would have
never
covered it.
assume. The thing, it's really difficult to know how...
If everyone else knows, I'll Wikipedia it, but I struggled in the last talk not knowing what the blockchain was.
If I can have 5 more minutes, I'll do a 5-minute intro to the blockchain.
Absolutely.
But don't...
Yeah, like I said, it's difficult to know, because sometimes, you know, when you get technical, half the room just lights up, and then the other half say, oh God. And so knowing kind of where to pitch, it's always a little bit tricky. So yeah, I think this could be quite handy. And also, you know, why it's relevant to the Internet of Things.
Yeah.
Right?
So Bitcoin is a ledger. It's a way to record transactions and say someone has transferred this value to someone else in some way. Just like the book that we showed, it records lines of money goes from this place to that place. Ledgers are easy if you have one person who sits there with the ledger and writes down everything that happens, and they're trusted. If we wanted to do one between all the people in the room and no one trusted anyone else, it would be really hard. So that's a lot of the problem that they're solving. So at root, it's a way to say, Alice has 200 bitcoins, she sends 50 to Bob, now Alice has 150 and Bob has 50, and now Bob sends some to Charlie. There's cryptography, so we always do Alice, Bob, and Charlie.
Sorry, Dave, just to jump in. But the fundamental problem, right, and what this is trying to solve, is that, like I was complaining about the internet per se being too centralized, the entire global banking and finance system is too centralized. So there's always this kind of blob in the middle between two end users called a central bank or a clearing bank, and it's very clunky, it's very inefficient and flipping expensive. When you want to actually shunt money from one person's bank account to the other, particularly if it's